Hi, Dr. Pat here. We're looking at quiz 4, number 2. This time we are taking that region that we have over here and we are rotating it around this axis of x equals -6. And so which method would be the most effective? I'm thinking shells would be. The reason being, with use of shells, I would have one integral, and the use of washers, I would have two integrals. Okay, so now looking at shells, what I mean by that is I'd have these vertical lines. Shells, the this is going to be a dx situation for shells. Okay, shells go parallel to the vertical of the axes, and so my shells here would have a thickness of dx. And a height, we'll be playing with the height. We're playing with the thickness. So it's a dx situation. And then the other thing that we need is radius. So what would the radius be of this situation? The radius would be the distance from the axes of rotation to each of these vertical lines, these hypothetical vertical lines there. And so to figure out that radius there, this r value, the r in this case is going to be the x value minus the vertical asymptote, or the axis of rotation at x equals -6. I'm doing x minus -6 instead of the other way around. The reason it's right minus left. And so just like our other situations where we do top minus bottom, we do right minus left. And so that's where I'm going to end up with a nice x plus 6 for my radius. Okay, and so I want to make an integral in terms of x's. My volume is going to be an integral of dx. And so the formula for shells is a nice 2 pi out in front coefficient. And my radius was x plus 6 as I calculated. And then now this in the bracket here is the height of each of these shells. The height of each of these shells is the top function minus the bottom function. Okay, so nice straightforward top bottom. And so that would be the f function on top, and the bottom function is the g function. So f minus g is what we'll have. And so what do I got? I'll have a 4 minus 2x, that's the top, minus the bottom function of an x squared minus 4. Close that off, dx. For my limits of integration, we're going from one intersection point to the next intersection point, and so we were going from -4 to 2. And there's my setup for using shells in this case, because it's in one integral. Now, if you did try to do it with washers, what I'm saying is that we have two integrals to play with, and the reason we have that is because when we play with this, whoop, there's my vertical line, try to get a little bit better. So when we do that vertical distance there, let's get a little green. Okay, so if we do this, now we have a problem right here. Because if we're gonna do washers, we're drawing basically horizontal lines. It's going to be a dy situation, and we're going to need to figure out who capital R and small r. Capital R is the radius on the the large radius, and then small r is the small radius. And the radius what we're looking for is the radius that comes from this distance from the graph to this axis of rotation, which is our x equals -6 line. So that's what we're looking for. Okay, so it's a dy situation, so things are going to be turned into terms of y's. So I need formulas in terms of y's. Now the problem that kicks in is right here where we have the top part of the region, the distance, the radiuses are nice, it's a line, and then the parabola. But when you go on to the bottom, you have to do a different integral because the r value here is the right over here, this section over here is the positive side of the parabola, and then the small r is going to be on the left side here, the small r, that's going to be the negative part of the parabola. And so what we have going on down there is that we'll have big R for the bottom part of it be equal to the formula in terms of y. So I'll be working that, and so that would be 4 minus no, excuse me, the square root, my bad, the square root of y plus 4 plus or minus a -6. So it's going to turn out to be a minus -6. So each of these guys are going to be end up being plus. Where did I get this square root of y plus 4? I went to up here at the g function here, and I solved for, I took this formula y equals x squared minus 4, and I just made it, converted into a formula of y's by adding 4 and then taking the square root. And when you take the square root of both sides, you get x equals plus or minus the square root of y plus 4. So the right side of the parabola is in terms of a positive square root of y plus 4, and then the left side is a negative square root of y plus 4. So the small r here on the bottom portion of this region, the yellow part right here, that is going to be the negative version of the square root of y plus 4. And then minus a -6, which will turn out to be a plus 6. So this will also turn out to be a plus because of those two negatives. And so those are our two radiuses. So when we put that all together, excuse me, what's it going to look like? The volume is going to end up being two integrals. We have the bottom portion from -4 to 0. That's the y values. And we are using washers, so I've got the square root of y plus 4, the positive version of it, plus 6. That's the outer, the large r value. Put that in parentheses, square it, minus. Now the small r value, the inner radius, that would be the negative of that square root of y plus 4, plus 6. Okay, and then that's a dy. So that's the bottom portion because it's the difference between the two halves of the parabola, and then plus the top portion of the region, and that's going from 0 in the y value there of the intersection up here. So this intersection up here, the y value is 12. And then we are once again using capital R for the outer radius, and that is going to be 4 minus y over 2. Now where did I get that? That's just going up here to the f function and then solving, doing the same thing here. So y equals 4 minus 2x, and then I solve for x and I get x equals so that's a 4 minus and then divided by 2. So 4 minus, so I subtracted 4 and then divided by -2 and worked the signs of things. Okay, so that's where that is. Again, minus a -6, so that turns out to be a plus 6. Okay, so that plus 6 is all about doing a minus a -6. And then minus the small r value, and the small r value would be the negative version of the parabola. So negative square root of y plus 4, and then plus the 6. And whoops, can't get my 6's looking good. And there we go, dy. Okay, so I would go with shells in this case. As you can see, it's nice, straightforward one integral. Where if you're using washers, if you're going to use it, it's a little less effective because you have to come up with two integrals. Thanks, and have a good day.